All right, welcome back to Easy Math with Nick. Today we are on video number 7, and our topic is finding the inverse of a 3 by 3 matrix. Before we start, a little bit of a disclaimer here. The process we'll be using to find the inverse of such a matrix um, is tedious to say the least. So if there's some downtime where it seems like I'm not talking as much toward the end of the video today, just know that yeah, I'm still here, and I might just be thinking for a couple seconds. So just a little bit of a disclaimer because I plan that I foresee that the end of the video might be a little bit tedious. But if you want to fast forward, I won't blame you. So I'll leave that to the viewer's discretion. And just another note here: I know this wasn't today's intended topic. I was supposed to, I think, cover, according to the list I posted in my channel description, today's video was supposed to be on. I was supposed to continue some of the AP Statistics 2025 exam free response questions. I'll pick up where I left off. I think it was video number 3, but that'll be video number 8 now, where I'll pick up on those questions. It was supposed to be video number 7, today's video, but I'll push that to whenever I make the next video, maybe tomorrow or the day after tomorrow. So without further ado, let's begin. So before we jump right in, just a little bit of a review of how to find the inverse of a 2 by 2 square matrix. So put it quite simply, oops, I was on the eraser for whatever reason. A inverse is the correct notation. 1 is 1 over the determinant of A, the original matrix, times D. This will make more sense when I write out original matrix. Probably started out with that, right? Where the original matrix is going to be A, B, C, D. So this is, believe it or not, I think I consider this a shortcut to find the inverse of a 2 by 2 matrix because it's easy to remember if you have the little visual that I learned in math class, at least, where you swap the A and D terms, so to speak, and make the ones in the bottom left and top right corners negative. That's a nice little diagram to remember. I'll circle it in red. But that is, and then multiply by 1 over the determinant on each of these individual components. And there you go. You have your inverse. And the property of that we'll be using to check whether we did our work right is when you multiply. I'm just going to say this verbally without writing it down. But when you do matrix multiplication between your inverse matrix and the original, doing matrix multiplication will yield a matrix that is the identity matrix. Regardless of the size, if it's a 2 by 2, 3 by 3, if you multiply the inverse, you'll get, of course, another square matrix, which will take the form of the identity matrix. If it doesn't, you screwed up. So hopefully we don't screw up today. But let me think for a moment, and then we'll jump right in. All right, let's begin. Okay. Okay. Now, just with there's a little bit of an implicit assumption that we're going to be making before we begin, and this is something that is the same for any square matrix, including 2 by 2 matrices. If you see here with the formula we have up here, the determinant of A, which is AD minus BC, so the A element minus times the D element minus the B element times the C element cannot equal 0, because then we have 1 over 0, and that's not good. We don't like that. So this carries over when we're doing 3 by 3 matrices, when we want to find the inverse of a 3 by 3. Even though a 3 by 3 matrix, there's no, to my knowledge anyway, there's no nice general formula like this that we would use to find the inverse, as we'll see in a moment. So, but still, there's that implicit assumption. If we just start right off the bat that our determinant of the matrix C is not of the matrix is not equal to 0, because if it was, there would be no inverse. So let's say, just as an example, I'll make this up. Just to go over, find the determinant of a 3 by 3 matrix. We had the matrix 1, 2, 3, 4, 5, 6, 7, 8, 9. Some of you might already know the determinant of this just just offhand, but keep an element of surprise here. So I forget the technical terms of minors and cofactors, so I'll just scribble what I'm in my thought process here. So I choose 1. I think that's our minor, I think. I don't know. But our little matrix, mini matrix that we'll be taking the determinant of is 5, 6, 8, 9. This is to find the determinant of the 3 by 3 matrix. It's alternating, so next we're going to have 2. Oops. 2, I meant to swap to eraser. This is going to take a minute, but it's just to go over how to find the determinant of a 3 by 3. So now we're going to have 4, 7, 6, 9. Oops. And just to clarify, when we have a matrix within bars like this, let's say A, B, C, D, this is just this just indicates that we're taking a determinant. We're finding the determinant in contrast to standard matrix notation. I'm sure most of you know that already, but just in case you didn't, I'm sure that clarified it a little bit to make what I'm doing not look like absolute nonsense. Which it still probably does, but whatever. So we have that number 3, and then we're going to take the determinant of that little matrix I just made there. So that's an 8. It does look like a 6, but it's an 8. All right, now let's speed this part up, because if I don't, this video is going to be way too long. So 5 times 9, R8 times D is 45 minus 48. So we're going to get -3. Minus 2 times, what's 4 times 9, 36, minus 42, -6. Plus 3 times 4 times 8, 32, minus 35, -3. So we're going to get -3 plus 12 minus 9. Ooh, that turns out to be 0. Okay, so with our original matrix that we started out with here, it would not have, there would be no inverse. There would be no inverse matrix because our determinant was equal to 0. So I think it's safe, I think it's okay to say that inverse is undefined. For this little example that we had here. But let's now pivot to a matrix that whose determinant is not equal to 0. So the example that I have written down here that I know is a fact will not take forever, hopefully. Hopefully in air quotes there. You know, I'll say B instead, because this is different, just to illustrate this different. 3, 7, 9, -1, -4, -7, -4, -7. I ripped this example straight out of some math textbook that I used to have. Okay, that I still have. I am not pirating, God forbid. And what's the inverse? That's what we're looking for. Boop, 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 boop. The inverse of our matrix. That's what we're trying to find out. So, all right, let's finally get to the title of our video here, almost 10 minutes in. So starting out here, what we're going to want to do is, in my own unique words, we're going to want to tether our original matrix to our identity matrix. And so, notation-wise, it's going to be B. Note I haven't taken linear algebra, so there might be more technical ways to state this. I'm going to say I is our identity matrix. I don't know if that's correct either, but 379, -1, -4, -7. And we're going to have our little dotted lines here too. And on the right, I have the 3x3 identity matrix. It's going to look like that. So our goal here, let me fix that. Our goal here is to essentially get the left side here to look like the identity matrix that we have on the right. So we are going to do what are known as row operations to get the left side to look like the right. And then whatever we end up on the right is going to be, whatever's on the right after we get on the left side to be the identity matrix will be our inverse matrix that we're trying to solve for. And at the end, if we haven't used up enough time already, we'll multiply that inverse matrix by our starting matrix and see if we get the identity matrix. And if we did, we did it correct. But if we don't, we messed up somewhere, which is more than possible because there's a lot of steps here, and I warned you as the listener that this could be pretty tedious. So without further ado, let's begin row operations. So what is going to be our first plan of action? Okay, I'm going to start out here. We'll keep in the color green. -2, row 2, plus row 1. -2, row 1 plus row 2. That's what I meant to do. -3, row 2. I think that's actually what I meant. -3, row 2. Wait a minute. Give me a second. All right, I accidentally, I paused it, and then I accidentally clicked save, so it's going to be split into 2 clips by accident. The UI that my device has here is very, very silly, very, very stupid, for lack of a better term. So my apologies if there's a weird gap in the footage. That's just how it is. Okay, I'll have to find some editing app to put the 2 videos together. Whatever. So as we're doing here, let's do 3 times row 1 plus row 2. And just to clarify, this is our first row, this is our second row, this is our third row. That wasn't already obvious, but just to formalize that. Okay. That is really silly how my program works here. Whatever. All right. So this is going to look like, I'll shift back to black now. Our row 2 is what's going to be changing here, so our row 1 stays unchanged. Our row 2 is going to be now 0, 1, 3. Because -3 times 1 plus 3, 0. -3 times 2 plus 7, 1. -3 times 2 plus 9, -6 plus 9, 3. Now we got to do the same. Whatever row operations you do, don't forget to also do them to the right as well. So we're going to get -3 times 1, which is plus 0, which is -3. And then whatever number times 0 plus 0. Oh, wait, there should be a 1 here. Oops. 1, 0. And then row 3, we haven't done anything today yet, so that's the same. All right, so next, what do I want to do next? I'll do 4 times row 1 plus row 2. I'm sorry, plus row 3. This is going to get us, now row 3 is changing. I'll change row 1 next. So 4 times 1 plus -1, 3. 4 times 2, 8 plus -4, 4. 4 plus 2, plus -7, 1. Boop, boop, boop. 1, 0, 0. -3, 1, 0. 0. Oh, row 3 is going to be changing. So what's our row 3 going to be now? 4 times 1 plus 0. 0. 4 times 1 plus 0. 4. Okay, so if we look now, we have 1s in all the right spots in order to get our identity matrix. But we only have a 0 in one of the 6 spots that we want 0. So we're not quite there yet. So we might have to sacrifice some of the ones that we already have here in order to get to the point we want to get to. Unfortunately, but some sacrifices must be made. So next I'm going to do negative row 3 plus row 1. I'll do negative 2 row 3 plus row 1. That being said, I'm not quite sure if what I'm doing is necessarily the most optimal way. I challenge my viewers to do this in fewer amount of row operations than I am. I'll try to do this again off camera to see what the minimum amount of row operations I could get this down to. But maybe my viewers can be even more efficient than I am. So I wouldn't be surprised. So negative 2 times 3 is negative 6 plus 1, negative 5. Negative 2 times 4, negative 8 plus 2, negative 6. Negative 2 times 1 plus negative 2 plus 2, 0. So now we have a 0 in the spot we want to. Right? Row 2 and 3 remain unchanged. Row 1 is now going to be negative 7 here. 0, now negative 2 here. And remaining rows left unchanged. Please don't forget to also do your row operations to the right as well. It's a really easy mistake to make. I don't blame you if you make it, but try to avoid it because it's a very silly mistake and we don't like making silly mistakes. All right. Next up, have we changed row 2 yet? No. Okay, yes we have. We have changed row 2. We've changed every row so far, at least once. So now let's see what our next plan of action is going to be. Haven't done R2 plus R3 yet. Maybe that's where the route we want to take. Okay. Okay, I'm going to do negative 4. Okay, yeah, I think I know what I want to do here. Negative 4 R2 plus R3. Row 1 remains the same. It's not 60, that's 5, 6, and 0. Because space that out a little more. Row 2 is also not going to change. It's only going to be row 3 that changes here. Like I said, sorry that this is a little bit tedious. I also had technical issues as well, which is horrible. But not a great day for that, right? Negative 4 times 3. Negative 12 plus 1. Negative 11. Negative 4 times negative 3. 12 plus 4. 16. Negative 4 times 1 plus 0. Negative 4. And then that stays the same. All right. Okay. Now, looky here. All right, we got zeros in more spots than we had before, but we only have a 1 in one spot where we would like it now. Not ideal, but next we're going to do 2 times R3 plus R1. Let's see if that's worthwhile. Yeah, I think that's a good idea. Yeah. Oh, let me go back to green. 2 times R3 plus R1. Back to black. So R1 is going to be 2 times 3 plus negative 5. 1. 2 times, there's going to be negative 6. That's going to be negative 22. Not the greatest, but whatever. Just a funny voice there. Just to reiterate, our goal here is to get the left side to look like the identity. So hopefully we succeed with that. But 32 plus 7, 25. Negative 8. Oh, and a 0 here. Okay. Rest of the rows remain the same. Are we changing row 1 with this? All right. What do we want to do next? Ooh, that looks very tempting. Negative 2 R3 plus R1. Isn't that tempting? I'm tempted to do it. I'm very tempted, but no. That would just undo the operation we just did. So I don't think that's the right choice for now. For now, at least, I do not think that's the play. I don't think that's the play because that would just undo what we just did, and we don't want to do that. All right, I'm gonna do 6. Okay, I'm gonna do 6 R2 plus R1. I'll go back to green. Like I said, there is most certainly a more efficient way to go about doing these old row operations. There's more efficient row operations to get to the same finish line that we want here. -4 now we have up here. No, 3. Okay, so that did more than you might think. That did more than you might think. Okay. I got a lot done, in my opinion. I think we're actually nearing the finish line now. As crazy as that sounds, right? -6 row 2. -6 times -3. I'm sorry, 6 times -3. Woo. -18 plus 25, 7. 7 up here. 6 times 1, 6. Plus -8, -2. Still 6 times 0 plus 0, 0. Rows 2 and 1 don't, I'm sorry, rows 2 and 3 don't change. Okay, if believe it or not, we're nearing the finish line here. And as you do problems like this, you'll have a better intuition of when you're nearing the finish line, so to speak. All right, now, without further ado, I'm going to do -3 R1 plus R3. I'm pretty sure this is. Now we can really optimize where we're going here. 1, 0, -4. 1, 3. So we're going to get 3, 0, 0, -3 times -4, 12, plus 11, 1. And look at that. Now we have one of our rows is the same as our identity matrix. Once you got to that point, that's when you know you're in a great position. So row 1 remains the same. Let me just double check I didn't forget to change row 1 between any 2 steps. I'm sorry, didn't forget to change any row between any 2 steps. Okay, I think I've been doing this right. All right. 3 R1 plus R3. Okay, so -3 times 7 plus 16. -21 plus 16. That's -5. -3 times -2. 6. -6 plus -4. 2. -3 times 0. 0 plus 1. 1. All right, -5. 2, 1. All right, so our bottom row is done. Great. But now we want to worry about the other rows, right? So we're going to do our row. We only need 2 more row operations. You'll see how I know that in a second. We're going to do 4 times R3 plus R1. That's going to get us. Ooh, look at that. We have 2 zeros here. So whatever we multiply that by, it's still going to be 0. So we're only adding 0 here, which isn't going to change anything. So we could specialize what we want to change. We multiply this by 4 to get that -4 to be a 0. So it's really easy at this point because you don't have to think 2 steps ahead like we're playing chess here. What you want to do is weigh right in front of you. So it's just going to be 0. Our first row is now good. Look at that. But still, we still want to pay attention to what we're doing on the right. What we're doing on the right didn't just disappear. We still have to worry about that. So we're not just absolutely booking it for the finish line. We still have to think about what we're doing here. Okay, 4 times 2, 8 plus negative 4. 1 plus 0. There you go. Row 2 remains unchanged. until next step where we're going to change it one final time. And our final row operation, I'll count how many I've done. Probably going to hit 10. I've done 1, 2, 3, 4, 5, 6, 7, 8. Okay, just under 10. We'll have 9 row operations by the time I'm done. This video might be an hour, half an hour long. Ooh, God forbid. So finally we're going to have -3, row 3, plus row 2. Might have seen that coming. But triumphantly, this is going to get us the identity matrix on the left. Isn't that what we wanted this whole time? Wow, look at that. Our row 1 was finalized last step. So that's good. Row 3 was also finalized last step. I'm sorry, 2 steps ago. So -3 times -5, 15 plus -3, 12. -3 times 2, -6 plus 1, -5. -3 times 1, -3 plus 0, -3. All right, so now that we have the identity matrix on the left, we are done. So whatever we have on the right now is going to be our inverse matrix. Wonderful. So as a final test, let's just preemptively celebrate by saying our inverse matrix is the following. -5, 2. Isn't that beautiful? Took us so much work to get to that point, almost half an hour of work, but it was worth it. And now, just to check, without a calculator, I could pull out a calculator, but that's not fun at all. What was our original matrix? 1, 2, 2, 3, 7, 9, -1, -4, -7. So it was 1, 2, 2, 3, 7, 9, -1, -4, -7. -1, -4, -7. All right. -1, -4, -7. Multiply that by our inverse matrix, and I am praying that we will get the identity matrix after we do this simple matrix multiplication. So we're going to get another 3 by 3 matrix. All right, so 1 times 13. I'm not going to draw arrows every time. 1 times 13, -1 times -13 plus 24, 11. 11 minus 10, 1. 1 times 6, 6 minus 10, -4. -4 plus 4 is 0. Good so far. 1 times 4, 4. 4 minus 6, -2. -2 plus 2, 0. All right, now moving on to the next row. 3 times 13, 3 times -13, -39. Whoa. -39 plus 84. -39 plus 84. 45. 45 minus 45, 0. Great. 18 minus 35. That shouldn't take long. 17. 17. I'm sorry. -17. -17 plus 18. 1. Looking good so far. 12 minus 21. -9. -9 plus 9. 0. Final row. This is it. All right. 13 minus 48. 13 minus 48, 35. Yes, 35. 35 plus 35, 0. I'm sorry, oops. -35. Okay, it's 13 minus 48. Okay, -35 plus 35, 0. -6 plus 20 minus 14. -6 plus 20 minus 14, 0. And -4 plus 12. -4 plus 12 is, sorry, I'm losing steam here. 8. 8 minus 7, 1. Look at that. We got the identity matrix. So this is how you know that this here is indeed inverse of matrix B that we started with. Check mark. And this is our original matrix. So there you go. Finally, we are done. So without even doing a recap at all, that is how you find both the inverse of a 2 by 2 matrix. We didn't do a specific example, but I gave the general formula most pre-calculus classes teach. And the inverse of a 3 by 3 matrix, which took forever. It took whopping, I'll count it one more time. 1, 2, that was our first, right? 1, 2, 3, 4, 5, 6, 7, 8, 9. Barely escaped double digits. Row operations to get our inverse matrix. Wonderful inverse matrix I circled in red. So if any of you know a different method to find inverse matrices, at least 3 by 3 inverse matrices, that takes a shorter amount of time than this, which I anticipate there is a better method. I think I saw online somewhere. I'd love to be enlightened because this did take forever. I'd love to know a faster way to do this without just pulling out a calculator, of course. And so without saying anything else, thank you. I think that's all I wanted to cover today. It took a while, but thank you for sticking with me. If you stuck it through to the end, I really appreciate your dedication, and watching this video means a lot to me. Thank you.